Colab, and we're going to see how we can use Gemini AI in Google Colab. And we are also going to explore Kaggle. Some of you might have heard about it. And we are also going to discuss how we can make a workflow out of these tools and just get started on AI. And we are also going to look at a dog versus cat classification model on the basis of images. And later on, we will answer any questions if you have.
So at the very beginning, we start with Google Colab. What exactly Google Colab is? It's basically a cloud-based Jupyter notebook. You don't need to install Python, you don't configure anything. You just open a link and just start coding. It's that simple. This is completely beginner friendly, as you don't have to worry about loading a lot of libraries and configurations. So you can just start coding in just a browser, and best part is it gives us free access to GPUs and TPUs, and so it is really good tool to start with machine learning and start building your own AI. So if you are someone who is looking to get started with AI or machine learning, this is the one of the best tool to get started.
Next up, it also has Gemini AI, which can be really helpful as beginners. Even when we were doing this presentation, we were looking up for resources and we were also facing some errors. Gemini AI really helped us to understand the code, and it helped us to debug if there were any errors.
So now we will show you how simple code generation can become using Gemini AI. We just gave it a simple prompt, generate Python code to load iris dataset and create histogram of sepal length. And guess what? Within seconds, just I guess 3 seconds, it generated the whole code and it was completely ready to run. And now we will see when we ran this code, what were the outputs.
So it displayed the first 5 rows of the flowers. So the columns that it gave: sepal length, sepal width, petal length, and petal width. And it also visualized, as we told it to, it gave us a histogram which distributed the sepal length over the histogram. So it gives us a really good idea of how we can get started. Even if we don't know anything about basic data set, we can just get started and tell Gemini AI to explain it to us.
So now here's the best part, that Google Colab has recently integrated VS Code with it. So it is a recent update, I guess mid-November, this mid-November. Now you can use Google Colab's GPU inside VS Code. So basically you get the comfort of VS Code IDE environment, those features like extensions, shortcuts, and IntelliSense with the background of Google Colab. So basically you get the Google Colab inside your Visual Studio.
But there are some things that Colab lacks in. So it does offer excellent features, but it has very limited data sets, and you cannot access community resources on Google Colab. So this is where Kaggle comes in. It bridges that gap. And next up, we are introducing Kaggle.
So this is Kaggle. If you are new to data science, this is your one of the best place to get started with. So it gave us access to millions of data sets, tons of notebooks, and best part, a very active community where they literally share their code, their own work, which is very helpful for us as a beginner. You can just look through those notebooks, those data sets, and it also offers some competitions and short courses which are really helpful to test our skills. So if you want to start with as a data science career, or you are starting your journey with AI or ML, this is the best tool to get started with.
So next as we generated the iris dataset in Gemini AI, we tried searching up the same dataset in Kaggle, and what we found was amazing. We found around 563 datasets of the same dataset, and when we opened one of the iris datasets, we found that further in that datasets, people have their own versions of the code. And you can just look up any code and analyze it, and analyze that how other people have written the code. And you can just simply download these codes and open them in Google Colab if you want to use them. Next up, integrated workflow. So when we were thinking about this, we kept in mind we had our journey in mind. We are first year students, and when we started our first project, I remember we had to use a model, but it was really hard to train a model from scratch because firstly you don't know much. We didn't know what was epochs, we didn't know what was tuning. But then later on, we found about Kaggle, and we just downloaded a pre-trained model and integrated with our Raspberry Pi. And it took less time, and we generated a AI facial detection expression system. It wasn't perfect, but it was a good way to start. And
That's why we built this integrated workflow using Kaggle, Colab, and Gemini AI. So you just start looking through a data set on Kaggle, and then you experiment it inside Colab. And you can ask Gemini to explain your code, debug your errors. And once you get comfortable, that's when training your own model becomes the natural next step. So now we will show you our own practical example of how we integrated this entire workflow while building this dog versus cat classification model. So we will go through this whole model in next few minutes. So now we will switch to Google Colab. So to be honest, we have used a lot of AI assistants, and including Gemini AI, TensorFlow documentations, Colab notebooks, and tutorials extensively while building this entire process. So it's completely normal, I guess, because data science is all about looking things up and figuring things out. So what we are going to show you isn't just a code, it's a learning journey, a problem solving process, and our understanding of how this entire workflow processes.
So in the first block of code, we just installed we installed and imported some libraries. So we are using TensorFlow and Keras for our model, for downloading it, and we are using Matplotlib for visualization. We are using PIL for loading our images, and we are using sklearn for the metrics. And so firstly, we got the data set from Kaggle. We copied the link of the data set so that we can download it. Next up, we have a code for data cleaning. So basically, it is a good practice to clean your data, because if there is any corrupted image or the image that can't be opened, it will automatically delete it. And it will check the data sets from dog or cat. So the data set we downloaded had 500 images each for dog and cat. Usually when you train a model, you have more images, but this is just a demo, so we took a smaller data set. So then when we ran the code, it downloaded the data set 100%, and then when it checked, there were 0 corrupted images, and so we still have 500 images each.
So now here comes the important part, preparation of our data sets. So we load the data, and then we resized each and every image to 60 by 60, and then we set the batch size to 32. After that, we splitted our data set using a 80 by 20 split. So we used 80% as a training set, and we used 20% as a temporary validation set. But in actual, as we know that we need 3-way split, validation, training, and testing. So we splitted that validation into 2 halves. So we used the first half as testing data set and the other half as validation set. So now we have like 80% training set, 10% validation set, and 10% testing. After that, we printed out the data split, the number of batches for each of them, and then we also grabbed the name of classes just to verify that our TensorFlow has detected those categories correctly. And then we did an important part here, optimization of our data set. By caching or prefetching the data. And after we ran the code, as we can see here, we got 1,000 files that are belonging to 2 classes. Those are basically cat and dog. So we are having 800 files as training, which is basically 80%. And then we are having 200 files for validation, which is 20%. And then we printed out a data split. We are having 25 batches of training and 4 for validation and 3 for testing.
Next up, we visualize the sample images. So this step is important before you train your model, because once you have trained, you cannot go back and see if your data set was loading correctly or not. So basically we check that is our data set labeling the images correctly. So from our data set, is the cat actually a cat and is the dog actually a dog? So like doing a sanity check on our data set.
So here comes the most important part, building of our model. So we didn't build a CNN from very scratch. We used Google, we loaded the Google's MobileNet V2, which is already being trained on millions of images. So it already recognizes those visuals, patterns, shapes and edges. So we are basically borrowing that whole information that it knows. And then after that, we freeze that base model. So on top of that, we added our own classification layers on which we are going to train our own model, dogs versus cat. And after that, we done the compiling of our models. So here we are having Adam as an optimizer, which is basically an algorithm for optimization of a neural trained network. And we are having a loss function here, which is basically, as the word binary suggests, it will get output like 2 outputs, 0 or 1. Like here we are having dog or cat, and we are using accuracy as a metric. And then we printed out our model summary. So here comes a fascinating part, that our model is having around 2.6 million parameters, and mostly all of them are marked as non-trainable. And we are only actually training on the top layers, which we added, which is around 1200 here. So our whole approach looks like taking a pre-trained model, and then we freeze that model, and then we add our own classification layers on top of it, and then we actually train our own model on those top layers only. So this is how convenient and efficient transfer learning. This whole process is named as transfer learning. I forgot to mention it in the starting. So this is how we can train a model or build a model, not from very scratch, but using a pre-trained model.
And then next comes the next step, which is training our model. So we have epochs of 10. You can choose whatever value you like. So epochs is basically how many times the thing is going to run through your model. So basically the model is going to run through your, it is going to train your model like 10 times. I have to say it in simple words. And epoch by epoch, you will notice that accuracy will increase. So in the first epoch, the accuracy was only like 0.55. And by the end of the 10th epoch, the accuracy has increased to 0.94, whereas the loss has decreased with every epoch. We can see that the loss was 0.76, and then it came to 0.13. And validation accuracy has increased, and validation loss has decreased.
So now we will visualize the same training history using a plot. So can you just So on the left side, we are having training and validation accuracy curve, and the right side, we are having a loss curve. So this blue line will indicate the training accuracy, and orange line will indicate the, orange line will indicate the validation accuracy, and blue line will indicate the training accuracy. As we can see in the very start, validation accuracy is above the training accuracy. So it is basically normal in a transfer learning technique, as the basic model is having those strong features already in the start. So in first few epochs, it is showing more validation above, like slightly more above the training. And after that, we can see that it is increasing steadily both ways. And on the right side, we can see that loss for both training and validation is decreasing, and it is also following the same pattern. So this visualization is important that rather than numbers, I guess visualization can give us a more insight of what whole process is going on. So it is really cool, and we can say it's cool to visualize because it gives a whole insight in a real simple way rather than just going through the numbers.
Next up, we will visualize the predictions on test set. So as we kept our 10% for the testing, so we are going to use that here because it was not used when we were training our model. So we are going to use that test set, and we predicted. We only took the first 9 images for visualizing the predictions. So the green color will indicate that the prediction is correct, and if there is any red color, it will indicate that the prediction was wrong. So to our surprise, there were no red lines in this particular visualization. So it, as in the first one, we can see that it predicted a cat is an actual cat at a 0.99 confidence, which is really good. And then it predicted, in the middle, it predicted almost with 1 confidence here as well. So it is showing that our prediction and our confidence rate of the model is really strong.
So now we will do the final evaluation on the test set. As we can see that our accuracy is around 96.88%, and we are having final loss around 0.15%. As we can see that our loss is really less and accuracy is really great. So this is basically giving us an insight that our model is not overfitting and it is generalizing the values really well.
Next up, we made this confusion metrics and classification reports. So in confusion metrics, basically it is telling that it classified around 56 cat images, out of which it classified 54 cats as cats, but it classified 2 cats as dogs. And then next up, there were around 40 dog images, and it classified 39 dog images as dog images, and one dog image as a cat image. And talking about precision, the precision value for cat and dog is 0.98 and 0.95 respectively. The difference between them is really like not much, which is a good thing, because if there is a difference in the precision, it means that the predictions may be biased towards one class. And next up, the next step.
So as we have trained our whole model, so now here comes the important part to save our model, and then we downloaded our model into our computer. So it is also important part because we have limited resources. As we have trained the model, so we don't get it like wasted. So we save it as we can reuse it inside of like any of our other project, and we can share this training project with anyone. And even if we want to classify an image of dog or cat, we can just call this downloaded model, and we will be able to classify a dog or cat, which we are literally going to show you right now. So
this is what we did before coming here, but we can do it again live. So if any one of you can share or like airdrop any dog or cat image, we can test it out right now. Yep, so our model is just loading. It might take a bit of couple of seconds. Is anyone interested in sharing a picture of their dog or cat with us? Yeah. Yeah.
What's your airdrop?
Just it could be iPhone, I think.
CR2 iPhone.
Oh, sorry.
Keep them there.
If you can just go closer,
Yeah.
I can just do the tap. Yeah.
thank you so much.
Sorry, it might take a bit of time.
So basically, no model is 100% accurate, as we have also seen that our model accuracy is around 97%. So let's see what it does. Is it taking long time? So it might detect it as wrong. So we will see. Fingers crossed at this point. So let's see. Waiting time over, guys. It predicted cat as a cat with 92.2% confidence. So tonight, when you go home today, don't overthink, don't panic. Just start looking up with any data set on Kaggle, open it inside Colab. Even if you don't know what's going on, that's completely fine. Ask Gemini to explain code, debug errors, and guide you step by step. And start building something. Anything, literally anything. A tiny classifier, a tiny predictor, or messy environment, it doesn't matter. Because
your first AI model won't change the world and it won't be perfect, but it will still give you an intro to the AI world and you'll get started. So just start. So tonight,
don't scroll, build.
Thank you so much.
And we are happy to take any questions if you have.
That's a simple question. In case that the image is corrupted, or like let's say some users like low light and all those kind of factors, how does that affect this
So to my knowledge, as we have before training our model, we have done the data cleaning, which is really important step. So it will basically delete those corrupted model from your images before going through training. So it's an important step to do data cleaning beforehand.
Does it integrate with any other data set providers such as Hugging Face, for example, or is it only Kaggle?
So our model, you can use any other data sets, but our model, the top classification list that we have added, was of cat and dog. So our model will just predict cat or dog as a cat or a dog. But if you want to make any other image classifier, you can use that same Google Mobile Net V2 because it's having millions of images, and you can add your own classification layers on the top of it.
Put a picture of yourself in to see whether you're a cat or not.
We can do that.
So what is serverless? The serverless doesn't mean that it doesn't use no servers. It means that you don't manage them, basically. So it has features such as auto-scaling, pay-per invocation, event-driven, and zero maintenance, because Google Cloud does basically everything. It auto-updates and it is secure and stuff like that. So you don't have to maintain them. Then we have what is serverless AI. So it's basically a cloud function, which I usually mention later what a cloud function is. And then we have it triggers on HTTP events. So that is why you don't need a machine learning engineer or what you want to train train a LLM on it, because you just need to know what the HTTP is and what the event is for that in your code. And that calls an AI model, which is Gemini, GPT, Vision, Claude, whatever you want to use. It has no servers required because it's serverless. And now Ayush will present the cloud functions and cloud runs.
Thank you, Dharia. So Google Cloud is a platform that provides a lot of infrastructure and stuff. So there's a lot of services, and two of the services I'll be talking about is Cloud Functions and Cloud Run. So Cloud Function, what it does is it's a lightweight computation. So it doesn't require a lot of things. It's single purpose, single base. So it's best for notifications, small AI tasks, webhook. So there's short execution time, and it really allows for single tasks. Whereas Cloud Run has more serverless containers, it's full control, and runtime dependencies are just the full environment. So it has high memory CPU, better for AI workloads that are harder. And so Cloud Functions is good for small AI calls, and Cloud Run is good for consistent, heavier or parallel AI workloads. Yep, so why using serverless AI is important. So simple code can be done by the powerful AI, and it's really fast to prototype, so rapid prototyping doesn't take long at all. You don't have to worry about the infrastructure. It's very cheap to run, and it's perfect for one-person teams and really easy to integrate into full-scale applications, so the scalability is there and it doesn't require a lot. And it's used heavily by startups now because of how easy and how easy it is to integrate into the applications that they are building themselves. Slide. So how serverless AI works, the architecture. So basically what happens is a user can send a HTTP request that triggers an event, and serverless functions run instantly on the cloud. Functions can call to something like Gemini for inference, and Gemini processes use Google's GPU infrastructure that is already installed on the cloud, and responses are returned very quickly. So data is sent into the cloud function, as you can see here, and there's an output that goes into the machine learning model, and that can allow for real-time analytics, anomaly detection, and chatbot. So the key ideas around this is that it's event-driven, it's stateless, there's auto-scaling, and there's no need for servers or GPs to manage anything, so you don't have to worry about the overall infrastructure. Google Cloud does everything for you. All you have to worry about is small amount of code, not that much at all. So here's some code that we have written as an example for serverless AI. So it uses Python as the programming language and a Cloud Vision API. So basically what is happening is it uses a HTTP framework to get a request for an image URL, and if it doesn't exist, it sends an error message, and we create a client to hold that API, and then the image equals vision.image. What that does is basically it creates an empty container where you can hold the source image URL, and then that calls to the Cloud Vision API, and that is used for label detection, which just gets the objects and the descriptions and everything, the scores, the accuracy around it. And then we have safe search detection as well, which is used for clear safe detection. So if there's any adult content, inappropriate content, it can find that out and see the likelihood of it, and if it's safe for certain ages or certain people as well. And then that returns everything as a JSON response at the end, so the user can clearly see what they have gotten back. Next. So real world use cases for serverless AI is that it powers real-time moderation, OCR extraction, audio transcription, smart chatbots, thumbnail generation, auto summarization, email classification, and these are actually used in the applications that you use today. So like Gmail, TikTok, Instagram, all of these use serverless AI, so they don't have to worry about the underlying infrastructure and can really focus on the functionality of the application as a whole. Next, so now we'll be doing a live demo of the serverless AI in action. So what we'll demonstrate is triggering a cloud function using a HTTP request And this function sends the data to the Vision API, and then the Vision API processes the input using its AI model, and then returns in the JSON format, as I mentioned before. So what this basically shows is the serverless computation and AI working together, and how simple ML inference becomes one with cloud functions in the Google Cloud platform. So real production style workflow in less than a second. It doesn't take much time at all. It's really cost effective as well. So yeah, we'll be presenting it now. Do you want to talk about it?
So what we basically have is Google Cloud, and we have a project based on that. So that's the project name if you're not familiar with the Google Cloud. Serverless AI, and what we'll do is we'll create an SSH, like open an SSH terminal. And we have already, just a pretext to this, we have already deployed the project on it. So we already have the URL for the Vision API and the database where it will all store it. And what we'll do now is we'll do a curl function command on it, and we'll get, so the curl is a JSON, the JSON request will go to the image, we'll send it an image URL, which is over here. It is a tiger image URL, which you can see here. Wait, let me just, if it increases the size. So this is the, okay, let's go from here. So that's the image object which it will store in the code, and we'll send it, the client sends the image URL with it, the HTTPS URL of the tiger, and this is our server's, the project's URL. So what we'll do now is, if it will mimic the client sending a request and then getting it from the AI. So yeah, basically what we get in response is a JSON reply which has the labels, description, and score of accuracy, what it is. It is basically all from the Vision API. We are not training it on our end. We are just using the pre-trained model. So that makes it easier for us, less cost and more efficient. If you want to scale it more, like if you want to change it something, if you want to change the logic of it, if you have business operations have changed a bit, so you can easily create, easily combine them and update them, because you don't have to do update every configuration in the model itself. So that's what basically a demo was.
Okay. So the final tips and takeaways. No problem. That's all good. Just give it a second. Yeah. So the final tips and takeaways from this is serverless simplifies deployments, because you don't have to worry about the underlying infrastructure. You don't have to worry about updating software or updating operating systems. That's all done by the serverless computation on Google Cloud, which we have shown. And AI APIs remove model hosting. AI APIs already have the model trained and everything, so we don't have to worry about that. It's perfect for small teams and students starting up, because there's not a lot of infrastructure you have to deal with. All you have to do is do what we did, show you, not much code at all. It's production ready in minutes, because there isn't much to do at all, and anyone can build these powerful AI apps using serverless AI as a whole. Thank you for listening.
Thank you guys.
Thank you guys.
Thank you so much, gentlemen. I didn't even get a chance to finish my KFC. That's okay. But we love short talks. I think the king of talks is the short talk. Now what I want to do is I want to open up the floor to questions. Let's have a few questions and get some real audience action on this subject. Who's got the first question?
Yeah, I was wondering, so you said serverless AI, but like, the the things you mentioned in the demo was essentially these services that Google has pre-rolled. I was wondering, is there a way to pre-train something and put it on the cloud? You know, like your own model, not using Google Cloud Run specifically, but using what's the cloud functions.
So you train a model on your local PC, and then you can upload it to, what you're saying is you can upload and then use that model as well.
Like a custom purpose.
Yeah,
sort of
custom.
like,
Yeah, I think that would be possible if you use by using online database, the SQL database that Google Cloud offers. So you can store your machine learning model over there. I think so, and maybe use that as a reference to when you call it, or like store it dynamically over there.
Another question? Yes.
So Google Cloud, sorry, I'm just from AWS. I haven't used GCP a lot. So Google Cloud Functions is basically the Google version of AWS Lambda, and Google Cloud Run is basically the version of AWS EC2, right?
Yes.
Yeah,
Pretty much.
yeah.
Yes. It's just pretty much the same thing. Serverless computation.
Yep.
I have a question, guys.
Yeah. Yes.
What's the pricing of it? Like roughly? How much does it cost? Because I think that's a big thing.
Yes. So I was researching about it last night because I also thought that. So on a free trial account, you get like 2 million invocations per month. So you don't pay if you go till 2 million invocations for it. So that's why it's cheap, and like for small businesses, I don't think it will go over 2 million.
That's a very generous free tier, by the way.
Yes.
That's a super generous free tier. All right, thank you so much, Ayushi Daria. Just a quick hand for them. Thanks so much, guys. Let's get the next question up.